This old Peterbilt head, they've been using that at the pumice plant, and that's all it's doing. It's kind of where they send the trucks to go die at, because it's a really rough environment for the truck to be in. But anyways, it's got a throttle position code, so just bear with me on this video, because I was kind of chasing my tail there for a little while. I kind of got myself confused a little bit because things weren't making sense. Sometimes the OEM troubleshooting trees, they kind of lead you astray. And sometimes their terminology and the way they're doing things doesn't make sense. But as you'll see as we gonna struggle along through here through this one, that sometimes it's easier just to get a wiring diagram out and look how it works, and then test the components or the wires yourself with your own knowledge than following the OEM troubleshooting tree, because sometimes, like this one, it was just kind of getting me confused as to what they were asking of me. Anyways, this one's got a 551 code in it. Here's our wiring schematic for our throttle position. That is 551 is idle validation shorted code, or low voltage. So here's our wiring schematic for this serial number, Cummins. This is, let's see, accelerator pedal assembly. You're going to have either, usually one of them, the Robert Shaw one's usually a Deutsch connector, and the Williams ones, this is a Williams one because it has this kind of connector here. 6 wire. Let me get my damn laptop out of the way. I'll knock it on the ground and destroy that. Get it unplugged here. I gotta get something to dig that connector. There we go. All right. So you can tell this one has A, B, C, D, E, F. So that code, I know for certain. I've wired so many of these things. They're a little different from some of them. These older ones with the 6 wires are a little different, the way their idle validation circuit works. First thing I'm going to do is check for 5-volt reference, which is going to be pin C. Pin C is going to be the 5-volt reference supply to the throttle pedal lever assembly. And I have 5.2 volts. Okay. And another way that you can check your signal returns, which is going to be pin number B and pin number F. So go from there to B, and I've got 4.987. Go to F, and I've got 4.978. So I have signal returns there, okay? So let's go into here. As you can see, here's our Williams Controls throttle pedal assembly, and I checked pin F. We have a signal return there, and we have pin B. We have a signal return there, and we have pin C, pin A, B, and E. Pin A, D, and E are signals. So let me go to this other one, to 551 code. I got it pulled up here. There they tell you to check for damaged pins and all that shit. Okay, turn key switch off. Disconnect the sensor from the OEM harness. Measure the resistance between the idle validation on idle signal pin and idle validation off signal pin. Okay. And this is one of those directions here that they weren't real clear as to whether they wanted you to test the actual sensor or the wiring, because they weren't real specific in their verbiage there. So I was actually started testing the wiring, because that's what I thought they were asking of me, and then I figured out later I was testing the wrong thing. Or I think, see, yeah, idle validation off idle, idle validation on idle, D and E. So then you're supposed to have 100,000 ohms of resistance there between D and E. Well, I'll have to reread that, but
we've got 37,000 kilo ohms, so 3,700 ohms. Okay, let's go back to that. That's what I thought. So that's 37,000 ohms. 37.5 kilo ohms is 37,500 ohms. So more than 100,000 ohms. There's nothing that says less than. More than 100,000 ohms. No. Oh, I see. No. Replace the SSS. Am I supposed to be checking? Check for a short. Okay. Am I supposed to be checking the? Wait a second. Check for a short circuit. Measure the resistance between the idle validation on idle signal pin and the idle validation of the connector with the pedal release and depressed. Oh, maybe they're not telling me to check the harness. I thought maybe they were telling me to check the harness, but I think I'm checking the wrong thing.
Okay, the audio was a little garbled here. So I figured out just an easy way to check this thing. And what I did is I pulled the throttle pedal assembly out of it. I put it in my vise there where I could access it real good and see the pins real easily. And as you can see on this Johnson Controls throttle pedal, it's really simple the way it works. It's switching signals. There's an off idle signal wire and a low idle signal wire. And the off idle is pin E, or the on idle is pin E, and the off idle is pin D. And all it's doing when you push the throttle pedal down, it's going to connect the off idle pin D to the signal return pin F, and then vice versa for on idle. You know, I get frustrated when I'm reading some of these OEM troubleshooting diagrams, and I just kind of get pissed off, and I just go do my own thing and figure it out myself, because they seem to go around in circles when they're explaining things, and they seem to go the long way around it. And you know, they'll do a 15-step procedure when you can figure out everything that you need to figure out in usually about 2 short steps. And I don't know, my recommendation on stuff like that, I guess it depends on what code you're getting. I mean, if you're getting a voltage low code or short to ground code, I mean, a real simple way is to just unplug it and just start checking continuity from the signal returns to all the other wires, or maybe all the other wires to, I mean, you can do that too. You can just check continuity between all the wires to make sure they're not. You'd have to unplug it from the ECM though. But what I did here is I just put it in the vise there and just put the ohm meter on continuity, and I went from pin F, which is the signal return wire, to pin E, and on idle you should have continuity, and there wasn't any. So then you can roll that throttle lever forward and go from pin F to pin D, which is the off idle, and then you should have an ohm reading or continuity through there. So, you know, it's telling the ECM that the throttle pedal's off idle, and that's just your idle validation switch. Now the other 3-wire part of that sensor is the actual throttle, telling the ECM how much fuel and how much RPMs the driver is requesting. But that's the reason this whole time his jakes weren't working properly on this, because it never was seeing an idle validation, which is kind of weird. This thing, when he came in and brought it into me, the first thing I did was unplug it to check my 5-volt reference and my signal returns to make sure they were present. And that 551 code wasn't there. The 431 code was there, but all I did was check voltage. I plug it back in, and all of a sudden the 551 code popped up, and then it wouldn't, all it would do was idle. It wouldn't do anything after that. But anyways, we replaced this thing, and that got her going again.
Guys, my buddy just bought this truck. This is a 1978 A model, what I call an A model, W900A. I love these trucks, I absolutely love them. I mean, boy, she is a clean one now for what it is. I mean, man, I like this sucker. Nice truck. Nice old Kenworth. Had a Cummins in it. So it's got a 13 and a 4 in it. It's what I call a 13 and a 4. It's got a Eden 13 with a Browning 4-speed in it. And what it's doing is, when he bought it, he test drove it, well, he drove it home from Medford, and it was popping out of gear. He didn't tell me how it was popping out of gear, so I just went and drove it. And what it's doing is, it's popping out of gear with the jakes on. So, must be some kind of detent or something that's not good in the Browning here. I was gonna pop this, the headache rack has got this deck plate, and then I think you can get the shift bar tower off the Browning after you get the headache rack and the deck plate off. See what's going on with that. So I'm gonna pull this headache rack, and then we'll just pop, and then I think that's all it's really holding, that deck plate on there. Okay, well, we got the headache rack off. And, you know, something I probably ought to check. I don't feel... shouldn't make any difference, really. I guess I'll pull these cotter pins out, and I can see that somebody's already inserted this one, so that's what we used to do to these all the time, is put steel inserts inside the aluminum frames, because the frames are always broke right there. Usually right behind the cab. That's where they always seem to break at. Oh, what are those? 5/8 and 11/16. The hell's going on there? That was 9/16. That's spooky. Trying to get her loose. Should be non-synchronized, so I would think. Trying to save that gasket if I could save it. Doesn't look like we're going to though. I mean, there's no synchros or anything like that to contend with. It's a non-synchronized transmission. I mean, you got to have your shaft RPM right. So nothing here is going, I wouldn't think. Unless we gotta. This would be where I would think my problem. There's the detents in here. So how do we get those out of there? Well, they seem to be locking in good, so. Can't seem to get this one in. There, okay. Let's see. Boy, they seem like they're working right. Huh. Get these bolts here. Bigger than that. Nothing on this side. Okay. That takes the tension off everything there. One spring. Should be a ball in there, I would think. Oh, I see. Yeah, it's got a little plunger of the ball. That's a simple setup. There's got to be one on the other side. You must have to pull this shaft out. That would have been the one that I would have thought would have been bad, but really, you know, that would have been the one I would have thought would have had a problem because it was a little looser feeling than the other one was. Sitting there trying to figure out how that shaft comes out of there because it's stepped. The shaft has got a step in it and it can't come this way. There's no hole on this end to get the shaft out of. So what the hell? How would that shaft ever come out of there? Is it like in there forever? Or what the hell's the deal with that? See how the shaft is, there's no knockout on this end or anything. There's a bushing here. How the hell? Oh, I see, it's a sleeve. Never mind, now I see how it comes out of there. It's a sleeve. Okay. Well, this one's kind of... That's what's making me wonder. See how these clutch collar teeth are worn off? They're not round they're rounded off. God, I bet that's what's causing it. These are all rounded off on this one. I bet that's what I bet that's what the deal is. He's trying to tell me that he wanted to take the Browning out of it. And I drove that thing in 13th gear, and shit, I don't think you could get over 40 miles per hour if you took the Browning out. When you put it in a higher range on the Browning, that gives you your higher ratio to get your speed up. I'm betting these rounded off teeth are what's causing that to pop out of there like that.